Hello, today we're going to talk about the importance of the equal variance assumption in ANOVA. ANOVA testing is a statistical method used to test whether the means of multiple groups are equivalent. In order to use ANOVA analysis, there are three assumptions that need to be met: normality, independence, and equal variance. Today we're going to be focusing on equal variance, which states within group variance is equivalent for all groups. One sample t-test were used to test the population means through a p-value that was calculated from the test statistic. The ANOVA analysis, however, uses the variances to calculate the F statistic to determine the p-value for significance testing. The F statistic or ratio is calculated by between treatment variability over within treatment variability. And the denominator is typically where the equal variance assumption comes into play. Since the ANOVA analysis is based on the variability of the data, issues such as potentially not having similar within group variance could have major implications on our test conclusions, since this affects our F statistic, which is what we get our p-value from. The violation of this assumption causes our ANOVA F statistic to become severely biased and can potentially lead to invalid statistical inferences. Heteroscedasticity can affect the type 1 error rate and lead to false positives. The effect of this unequal variance on the F ratio increases with more samples and unequal sample sizes. As the class notes state, the F statistic is fairly robust to heterogeneity of variances, but not the methods of ANOVA. This is why it's recommended on using techniques such as Welch's F test, transformations, or non-parametric tests if there is a violation of the assumptions. Which test to use is dependent on the other assumptions, such as normality. The four equal variance tests are Bartlett, Levine's, Brown, and O'Brien. Which one to use depends on the normality condition, the sample sizes, and skewedness. So what we use the equal variance tests for. So a low p-value from the equal variance test indicates that the equal variance assumption, the equal variance ANOVA assumption has not been met. However, a high value indicates that we do not have sufficient evidence that there is a violation. So we assume that the assumption is met. To show an example of the importance of the equal variance assumption, I conducted testing on the SAT by year file provided by the sample data in JUMP. I filtered and modified the dataset to show the following results. The final dataset is attached in the submissions. So the JUMP output shows that the ANOVA F test provides sufficient evidence to reject the hypothesis. This is shown right here, the low p-value here based off of the F ratio. So what happened here is that we could have conclusive evidence that the mean SAT score is different, is not equal to each other. So among these states, the mean SAT score is not equal to each other. However, when we test for the equal variance assumption, the equal variance assumption tests prove that there's a violation. Since there's a violation and the normality condition is met based off of this p-value from the Shapiro-Wilks test and the look into the residual plot, we have evidence that we can use the Welch test to properly test the hypothesis. The Welch test indicates that there is not sufficient evidence to conclude to reject the null. So basically, we don't have conclusive evidence. However, the ANOVA F statistic gave us conclusive evidence. The cause of this conflicting results is the equal variance assumption. This example shows us that the violation of this assumption, the equal variance assumption, can cause biased results and invalid statistical inferences. That's why it is important to check the equal variance when using ANOVA testing. Thank you.